All right, so we're going to talk about exponential functions today. All right, exponential, that means our x is in the exponent. It's in the little number spot. It's usually a number before the parentheses, a number inside the parentheses, and then it's raised to the power of x. That number before the parentheses, that's our y-intercept. The number inside, that's what's called our common ratio. We'll talk about those more in a little bit. So we got two problems here. We're going to show our Desmos strategy for this one. The points 3, 5, and 4, 10 are part of an exponential function, and we're asked to write that exponential function. For our Desmos steps, we're first going to add a table, so that plus table. We're going to put in our 2 points, or any 2 points if we're given more than 2, and then in a new line, we're going to type y1 squiggle a parentheses b close it to the power of x1. It's going to give us an a and b. We're going to fill in the blanks. We're going to put the a in the a spot, so in front of the parentheses, the b in the b spot inside the parentheses. So I'm going to go ahead and write my table right here real quick. We got the point 3, 5. We got the point 4, 10. I go to Desmos. We're going to add a table. So add table. I'm going to put in my first point, 3, 5. Then my next one, 4, 10. All right? Then in a new line, I'm going to type in y1 squiggle. If you need help finding that squiggle, if you don't remember, ask one of your teachers. A parentheses b close it. Then we're going to raise it. To raise the power, shift 6 x1. Gives us a bunch of numbers, but if you look right at the bottom, the parameters, we have an a, we have a b. The a is 0.625 and the b is 2. So the a in front of the parentheses should be 0.625 and the b inside the parentheses should be 2. So that tells me right away our answer is B. We're going to do the same thing here. I'm going to do the table method again because I want to practice that one. But if you're given a picture of a graph, and I made note of it on our notes, if you're given a graph the answers and see which one matches. I'm going to practice the table method again. So I'm given a graph this time. I have to identify 2 points. Well, I always like to do the y-intercept. That's 0, 10 here. And then we're given a second point, 1, 20. So there's my 2 points. That's the 2 points I'm going to put in my table. So I have 0, 10, 1, 20. Then in a new line, I'm going to type in y, 1, squiggle, a, parentheses, b, close it. Shift 6 raises the power of x1. Well, I have my parameters. I got an a of 10 and a b of 2. So in my a spot, I need to have a 10. And in my b spot, I need to have a 2 raised to the power of x. Looky there, b again, right there. Boom. All right, so now I want to talk about growth and decay a little bit. I have 2 examples on the right. I'm not going to work through them. I'm just going to highlight a couple points. But we're going to fill in this chart first, and we're going to look at the bottoms too, the bottom examples. Our a this time, still our y-intercept, but it has a new name called the initial value. It's our starting value, what we're starting with. The T represents time. The R is the rate. It's given to us as a percentage, but we want to turn it into a decimal. 1 plus R. On the inside, we have this little thingy. That is what tells us we're doing the growth model. We're growing. We're getting bigger. Right? And that's what, if you look down here at our example, we have 1.29. This is bigger than 1. It's a bigger number. It's greater than 1. So that's what tells us growth. That's how I know I'm growing, because it got bigger. The 1, it always has a 1 in there. But the 1 got bigger. It grew. So that's how I know it's growth. And like I said real quick, I'm just going to do 2 things in this. If you read through this problem, we see the word increases. That means getting bigger. It means we're growing. We grow. We're going to practice. If I have 5%, take our decimal. It's right there at the 5 right now. It's right after the 5. To turn it into a decimal, we're going to move it over twice. That's our new spot. Any holes we fill with a 0. So that's what we're adding on the inside. So on this one, inside the parentheses would be 1.05, and that would be raised to the power of t. All right? When it comes to decay, A still our initial value, the t is still the time, and the r is still the rate, and once again, percentage turned in to a decimal. Same three things. But now we have a minus. So that's what tells us decay. And if we look, we got 0.82, 0.82. That's less than 1. So that's what tells us decay. If I'm looking at an equation, I have this whole word problem, but it gives us the equation. That tells me decay right there. I look in that parentheses. Well, it's less than 1 now. So that's what tells us decay. It's getting smaller. It got smaller. And then once again, there's that word decrease right there. That tells us decay. Practice with our decimal again, 3.5%. Find our decimal, move it 2 spaces to the left. So now we get 0.035 for our decimal. And we would subtract that to where in our parentheses, where it's raised to the power of t, we have 0.965. So if I were to see that right away, I know I'm dealing with decay. And that helps us with some of our questions. Like this one. This was last year. An insect population after X months can be modeled by the function g of x equals 18 times 1.3 to the power of x. Which statement is the best interpretation of one of the values in this function? That's kind of up in the air, but I know that's exponential. Let me read my answer choices. The insect population increased by 13 insects each month. The insect population decreased by 13 insects each month. The insect population increased at a rate of 30%. The insect population decreased at a rate of 30%. Well, if I look, I got 2 increases, I got 2 decreases. So I know I'm dealing with growth and decay. So let me look at this number inside the parentheses, because that's what tells me growth or decay. Well, this 1.3, that's bigger than 1. So since it got bigger, that means it grew, because we always start at 1. It grew, we're growth. So we need to increase. So I'm looking right there. I know I'm increasing. I can get rid of the ones with a decrease on it. Well, if I go back to my models, flip it over real quick. You don't have to. With growth model, what I'm adding is the rate, and that's always the percentage. So knowing that, the insect population increased by 13 insects. The insect population increased at a rate. Ooh, there's that word rate of 30%. Well, I know that's what got added to 1, so that's my answer. All right, so we didn't have to do a whole lot. We just took what we knew about growth and decay. Last slide I want to go over, talk about exponential attributes, okay? Biggest strategy here is graph and check, but we can do a lot of these. We can fill in automatically. Remember our A, once again, y-intercept. B is our common ratio. We can always find these from the equation. So I have 5 times 1/2 raised to the power of x. Well, I know that number in front, that's my y-intercept, that's 0.5. The ratio, that's in the parentheses, 1/2. These next 4 never change. They don't. X-intercept, we don't have any. Asymptote, always, y equals 0. Domain, always, all real numbers. Range, y greater than 0. If I were to turn 1/2, oh, never mind. The way we check for the growth or decay, graph it real quick. So let me X out of my old Desmos stuff. I'm going to type in f of x equals 5, parentheses, 1 divided by 2, close parentheses, raise it to the power of x. It's decreasing, it's going down, so that tells me decay. Oh, I circled it, but you can't see it. All right, 27, this was a question on a test. What is the value of the y-intercept of the graph? H of x equals 29 times 5.2 raised to the power of x. This was the fill in the blank. Whenever they ask us what the y-intercept of a graph is, well, let's just graph it and look. 29, parentheses, 5.2, right? 5.2. I can't see it. It's a little cut off. Yes. Close it. Raised to the power of x. Well, I can't see where we cross the x-axis yet. So I'm going to zoom out until we do. I can see it there. Boom. It's at 29. Done. That's it. So, hope this helps. If you have any questions, ask your teacher. Yeah.